everyone. My name is Mete Atamel. I am a developer advocate at Google. And today I'm going to talk about choreography and orchestration in services. As you can see, I crossed out this serverless micro part because I realized that the things that I'm going to talk about in my talk, they actually apply to any kind of service, not just microservices or not just serverless services. It can be serverful services as well. So that's why I took that part out. These slides are on speaker deck already, and the demos that I will show you, they're already on GitHub, and I'm going to share the links at the end of the presentation. So everything you see today that you might find interesting, they will be available to you after the talk. All right, so first of all, what do I mean by choreography versus orchestration? By the way, who has been in the event-driven microservices talk before? Anyone? Okay, so that talk was a really good introduction to this talk, I think. So if you've been there, you saw the benefits of event-driven architectures. And what I'm going to argue about is that event-driven architectures are great, but they fall short in certain ways. And I want to talk about orchestration and how orchestration helps for that. So let's keep those event-driven benefits in mind, but my argument is that it actually falls short, so let's look at what we can do next. So let's imagine that you're building an e-commerce application, right? And this is a very simplified e-commerce application. You're trying to sell something, and you might have some microservices. So let's say you have a front end that receives a request from the user. Then maybe you have a couple of microservices that's related to e-commerce, like a payment processor to process the payment, a shipper to get the shipping details, and then finally a notifier to let the user know that the item has been shipped. Now, how do you design the system? One easy way is to basically chain your services, right? So each service makes a call to the next service in the chain, and that's an easy way to think about it. So what I call this is the simple REST-based approach. And there's some pros and cons in this approach. The pros is that, first of all, we broke down our monolith, so we don't have a single monolithic application. We have microservices, which is good, as we've seen in the previous session. And this is very easy to implement. All you need to worry about is, okay, this is my service, and this is the service, this is the next service that it needs to call. So it's easy to reason about. On the other hand, you already have all these problems. So you have too much coupling between your services. So each service has to know the next service in the chain. Each service can be a single point of failure. So if something fails in the middle, the whole chain kind of breaks. You need to have this error retry logic implemented in each service. Because let's say you call the next service in the chain, but it's down. What do? You need to do some kind of error handling or retry handling. And for me, the biggest problem is that who ensures that the whole transaction is successful, right? How do you make sure that this whole checkout system is actually working the way it's supposed to work? By the way, there's Saga pattern that we'll talk about as well. That will be useful for that. But in this simple model, we are not really doing anything special. So even though this is simple to do and think about, it really doesn't work in the real world. So what you can do is you can do what's called choreography, or also known as event-driven kind of architecture. And in this architecture, what you have is that you have your microservices, and you have a message broker or a message bus. And these microservices, they consume events and they emit events. So the front end receives the request from the user. Then it will say, order received. It will send a message. And then whoever is interested in that message will pick that message and act on it. In this case, we have the payment processor that will be interested in orders. So it will pick that message. It will do its own thing and emit another kind of message. Now, you might ask, okay, what is great about this? And again, if you were in the previous session, you will know, but just to recap, the pros is that your services are loosely coupled. They don't really know about each other, and they don't care about each other. Your services can be changed and scaled independently. Again, since they don't need to know about each other, you can basically do whatever you want with each service. You don't have a single point of failure. So if one of your services fails in the middle, the rest of your services, they can still send and receive messages, right? This doesn't mean that your transaction will be successful, but at least your system works in a semi-successful kind of way, right? And events are very useful when you need to extend your system. So if you need to introduce a new service in your architecture, all you need to worry about is just deploy the service, configure what kind of messages it needs to consume, and that's it. You don't need to touch the other services, which is great. Now, on the other hand, these are the cons. I think so the event-driven session talked about all the benefits, but there's actually some cons on this as well. Event-driven systems are difficult to monitor, right? If you have something failing in your event-driven architecture, it becomes really difficult to figure out where things fail. Like, let's say you send a message. How do you ensure that that message was actually consumed by a service, right? That becomes quite difficult. Secondly, these errors, retries, and timeouts, they're still hard. Let's say you send a message, but that message was not consumed. What do? Do you send it again? Do you need to retry processing it somewhere in some other system, service? So these problems, they're still there. Like just because you're using event-driven, they don't go away. And then in the event-driven systems, you kind of lose the business flow of your application. So if you have a flow in your application where it's very easy to see, and you take that and you convert it into services that just act on events, then that flow is not captured anymore. And that useful information is basically lost in your architecture. And again, this problem of who ensures that the whole transaction is successful, it's still there, right? So each service might be doing their own bit, but there's nothing watching your whole transaction, whether it's successful or not. So it's helping, but it's still, we still have some problems to solve. And imagine a more complex transaction. This is probably more real-world kind of transaction when it comes to e-commerce, where you're, talking to a database. Then from the database, you check whether something is in stock. And then depending on whether you have things in stock or not, you have different branches. And maybe you're using third-party APIs, supplier API. And maybe you're using SendGrid to send your emails. So you see here, there's databases, there's external services, there's third-party services, right? And when you look at this flowchart, it's very obvious what should happen, right? There's this nice flowchart that captures what should happen. But once you take this and convert it into services that sends events, then you kind of lose this flowchart. And I think that's a shame. We should really try to capture this and make sure that we can trace through it as we're running our architecture. So what can you do? You can use what's called orchestration. And the idea of orchestration is that instead of services calling each other, and instead of services sending and emitting messages, you can have an external service, an orchestrator, that orchestrates the calls to your services in the way that you define. So the idea here is that you define an orchestration in some kind of a language, and you deploy that orchestration to an orchestrator, and then when you receive an order, you start the orchestration, basically. You kickstart the orchestration, and this orchestrator will look at the definition of what should happen in what order, and then it will call the services in the order that you defined. It will get the results from each service, and it will pass it to the next service, right? So it will direct those calls to you, for you. So what are the pros and cons? And as you see, like everything has pros and cons. I don't believe that there's one magical solution. If there was, we would all be doing that. So when you're looking at these different solutions, you need to think about, okay, what are you gaining, but what are you losing at the same time? So the pros in this case is that, first of all, you have this central service where you can capture this business flow. And that will be very useful, and I'll explain later why that's very useful. But there's basically a definition of how things should flow, and you can capture that, you can version that, and you can change it as you go along. Secondly, there's this notion of steps in orchestration. So you have an orchestration with distinct steps. And if something fails in these steps, it will be very easy to see which step failed and why. So each step can be monitored, and the error handling becomes really easy because you see where things fail. These errors, retries, and timeouts, you still need to do them, right? So if service is not working, you still need to retry, or maybe you need to apply some kind of error policy. But now they can be centralized. Instead of trying to do all of this in your microservices, you can actually apply them at the orchestration level, and that lets you not worry about these external things like errors in your microservice code. Instead, your microservice can focus on the business problem that you're trying to solve. And services are still independent, and that's the beauty of orchestration. So you still have independent services, so you still get the benefits of independently scalable and independently upgradable services, but you're kind of putting them together into what I call a temporary monolith, basically, using orchestration. So you get the benefits of both worlds. You get the benefit of independent services, but at the same time, you get this coupling that you need for your orchestration. Now, on the other hand, this orchestration service, it's a new service to learn and maintain, so you need to keep that in mind. It can be a single point of failure. So if your orchestrator goes down, the whole chain still goes down. So you need to make sure that this orchestrator is actually resilient, redundant, scalable, all that kind of stuff. And you lose a little bit of eventing flexibility. So if you need to introduce a service, you need to deploy the service, but you also need to change your orchestration and deploy the orchestration as well. So it's more involved. So it becomes a little bit more difficult to extend your system. And this problem of how do you make sure that things are still working, now in orchestration, it becomes easier to detect failures. So if something fails, you can see it much easier. But then you still need to take action. Let's say a service fails, and you need to unroll some transaction. You still need to do that. And again, the saga pattern helps here, and I'm going to show you how to do that in orchestration world as well. But you still need to think about this. It doesn't magically go away. So the question is, like, which one is better? Like, which one should I use? And the answer is, it depends, as in all answers. But I think in general, if your services are not closely related, and they can exist in different bounded contexts, right? So let's say you have a notification service, and that notification service can be part of a checkout process, but it can also be part of some other process, right? In that case, maybe it's better to have that service as an event-driven kind of architecture. You just plug it in as with events, because it can exist in different contexts, and the other services, they don't need to know about it. So usually that's when I start thinking about choreography. On the other hand, if your services are closely related, they're usually deployed together in the same order, then that's when I start thinking orchestration. Because if they're always deployed in the same order, if they have certain dependencies with the order or how things should happen, then maybe you don't really need them in an event-driven kind of loosely coupled architecture, because maybe it is better to put them together into an orchestration. Also, if you can describe your logic on how things should flow in your system in a flowchart, then that's when I start thinking orchestration, because it would be really great to capture the flowchart and version that flowchart and deploy the flowchart, and if something needs to change in the flowchart, you change it and apply it to your orchestration. So these are some of the guidelines I use when I'm deciding between choreography versus orchestration. But again, they're not hard rules, right? You need to look at your system and depend on how much flexibility do you want versus how much structure do you want. And depending on your requirements, you go with one or the other. And also, it's not always a choice, right? You can also have a hybrid approach. And I think this is what I see most often, where you orchestrate things that need to go together into an orchestration, but then you use events to signal to other orchestrations. In this model, things that they need to go together, they're bound together, but at the same time, if they don't need to know about other orchestrations, they can just send a message, or they can just receive a message to start their orchestrations. All right, so that was a really quick introduction to what I mean by choreography and orchestration and when to use one. So hopefully that was useful. Now, when we look at this landscape of services and tools for choreography and orchestration, I think event-driven systems, they've been around for a long time. So if you are using AWS, Azure, Google Cloud, or other open source projects, there's a lot of tools or services that you can use. So don't go and write your own event-driven kind of services. If you like open source, use Kafka. If you're on cloud, there's many services. So just pick what's out there instead of trying to build your own. In terms of orchestration, again, there's choice. It's less because it's something more recent. On AWS, there's step functions. On Azure, there's logic apps. On Google Cloud, there's workflows for service orchestration. There's also something called Apache Airflow, which is an open source project. and its managed version called Cloud Composer, which does mostly data orchestration rather than service orchestration. But these are your main choices when it comes to orchestration services in the cloud. And I did a little bit of comparison of, how do step functions, logic apps, and workflows compare. I'm not going to go through the table, but as you can see, they pretty much have the same base features. And when you go to more advanced features, what I've seen is that logic apps on Azure seems to be the most complete solution. They have a lot of features. Then workflows, they have most of the features of logic apps with some things missing. And then step functions, it seems to be more geared towards AWS. So if you're on AWS, and if you want to talk to other AWS services, then step functions is good. But if you want to orchestrate other things, then step functions is not that great. It doesn't, for example, let you call other HTTP services outside AWS. So that's why it seems to be only AWS ecosystem related. And there's also an open source project called serverless workflow from CNCF that's trying to define how to, it's trying to define a specification on how to define workflows, how to run them, and how to have tooling around it. Unfortunately, none of the cloud providers, they support this yet, so none of them based on this serverless workflow specification, but it's something that's being worked on, and it's something to look into. Maybe there will be more services that are based on open source specification coming in the future. All right, so that's the landscape, and now I want to look into Google Cloud's workflows just to give you an idea on what kind of things you can do with an orchestration service. I actually have some slides, but maybe I'll show you a live demo so that we don't have to look at so many slides. But what is workflows? Workflows, it's a service to orchestrate and integrate different services. So if you have code running on Google Cloud on, say, Cloud Functions, Cloud Run, or basically anywhere where you have code running, you can bring those into your orchestration. You can bring Google Cloud APIs into your orchestration. So if you need to call Vision API, PubSub, or any Google APIs, they can be part of your workflow's definition. But you can also bring external APIs. So if you need to call some third-party API from the cloud, as long as they're accessible, they can be part of your orchestration as well. I like this approach because, usually when you run some code, it's usually your code calling other services within the cloud and also other services outside the cloud, right? So you can kind of bring all of those together into a workflow. And that's what workflows allows you to do. So let's actually look at a simple example. Here, what I want to do is I want to just chain a few services. So let's say we have 3 services running in different places, and we want to just chain them together using an orchestration. How do you do that? Well, first, I need to deploy my services. So here I have a function, a cloud function that I'm deploying. It's called random gen. It just generates a random number. Second, I deploy another function called multiply that takes 2 numbers and multiplies them, so it's very simple. Then third, I have another function, an external function, from math.js that takes the log of a number, right? So this is an external API. And finally, the last one is a Cloud Run service. It's a service that runs containers, and it's called floor, which takes the floor of a number, and I deploy it as well. So here you can see that we have 2 functions, one external function that's outside the cloud, and one container that's in the cloud. So we have 4 services, and you can kind of bring all of those together into an orchestration. And to do that, what you need to do is you need to define your workflow. You can define that in YAML or JSON. And in this YAML, just to show you how that looks, we define first steps in our orchestration. So my first step, I called it random gen function, and I'm making an HTTP call to this URL, which is the URL of my function. And then once this call is made by workflow, the result will be saved into this variable called random gen result. So we'll make the call and capture the result. Now in the next step, I call my multiply function, Again, it's a cloud function, but then the call is an HTTP post this time, and the body of the HTTP post is the body of the result from the previous step. So here, I'm taking this random gen result from the previous step, I'm looking at the body of it, and then I'm picking the random from the body, so I'm parsing that basically here, and I'm passing that as the input to this function, right? So you can see how easy it is to get the result from the previous step, pass it to the next step. Next, I call my log function. Now you can see that this is calling the external API. And again, I'm doing the same thing. I'm getting the result from the previous step and passing that in as an expression, as a get expression to my URL, and capture the result to the log result. And finally, the for function, now this time this is a cloud run, so it's a container that's running that has some authentication. So it's not a public service, it's a private service, so that's why I'm passing the authentication. And the body is again from the previous result. And in the end, what am I returning? I'm just returning the result from the last step. So I'm just going to return the flow result. So that's how you tie things together. And if actually, let me show you this in the console. I have all these workflows, but I think service chaining should be here. And if you look at the source, you will see the same source here. And the nice thing is that from the source, workflows generates this flow chart. I mean, this is very simple. It's just straight services calling each other. But if you have something more complicated, it will show here. So it's very useful to kind of see what should happen and how things look in your architecture. And then if you go to executions, you can see that I executed this yesterday, I guess, or last week. But let's execute it again. You can pass in a variable here if you like, but in this case, we are not passing anything to our first step, so I'll just execute. And now this is running my orchestration, calling my services in the order that we defined. And you can see that it's running. And if you look at the logs, well, logs, they take a little bit of time to come up, but you should be able to see in the logs that things are being called in the order that you defined. And yeah, you can see the body or the result, but I think the execution is already done. Yeah, you can see that it succeeded. And there was no input, and then there was an output that says 4. So what happened is that all the services were called, and then the last function, well, last container, I guess, returned 4. So you can just believe that all the other services, they were called in the middle. But this is very nice, as you can see. Like, you can see what was the input, what was the output, and if something goes wrong, you will see that the execution is not going to be successful, and you will also see where it failed, and you can debug it really easy. So that's what workflows is about. And I think we can skip the slides, but just to go through them quickly, this is how you define it. I show you how you define it. It's either YAML or JSON. Then you get the steps. You can add the weight between your steps if you like, and a workflow can last up to 1 year. So you can have something running for 1 year if you like. And then you get this JSON parsing in the middle, where you can get the result, parse that result, and pass it to the next in the step. What else do we have? You can apply retry policies. So if you want to apply, let's say, an error policy of 5 times, if a service fails, you want to call that service 5 times in an exponential backoff kind of way, you can apply that policy in each step. Depending on what happens in a step, you can take different actions. So if HTTP 400, you can do one thing, or if it's HTTP 500, you can do something else if you like. So that logic can be part of your orchestration. What else do we have? So these conditional expressions and the third-party API calls is very easy to do. You can do sub-workflows, so you can containerize, you can basically extract workflows into sub-workflows and call them from multiple places. There's connectors, there's iterators, and callbacks. Callbacks is very useful if you want to have a human in the middle of the orchestration where you wait for a human input before you can continue in your orchestration. So you can see that there's a lot of things in here that helps you to build very sophisticated orchestration systems. And I show you how to deploy and execute your orchestration, but you can do it from command line like this, and you can also do it from UI, just like I show you. And also, you see that you get this nice flow chart from your orchestration. So that becomes very useful when you're running things in production. All right, so that's an example of an orchestration service, workflows. I think step functions or Azure Logic apps, they pretty much have the same kind of concepts. I mean, they call them different things, but it's the same kind of concepts. Now I want to show you some patterns that I see in orchestration. Now the first pattern that I see very often is combining event-driven architectures with orchestration. And I talked about this before as well. For example, I have this example on GitHub where I want the user to upload an image to a cloud storage bucket, and then I want that image to be processed with a number of services, right? The best way to do this is basically to combine event-driven and orchestration. Now, what I want to happen with this image is that first I want to filter the image to make sure that it's a safe image using machine learning. So I have this filter function. Then I want to label this image. I want to extract the labels out of this image using machine learning again. So I have this labeler function. Then I want to resize this image to a smaller size called resizer. So I have another function for that. And finally, I want to create a new image that has the original image, the resized image with the labels extracted from before, and I just want those labels on top of the image. So I have this watermarker function that does that basically. It takes the resized image and adds those labels. So as you can see, these functions, they need to go together, right? And they need to be called in this order. First filter, then labeler, then resizer, and watermarker. Because of that, it makes sense to put them together into an orchestration. It doesn't really make sense to make them event-driven, because then, they don't need to be loosely coupled. They need to be actually deployed and called in that order. So that's why I put them together into an orchestration. But then, I want the whole chain to be event-driven. And that event is when the user actually saves an image, right? So when the user saves the image, it goes to the cloud storage bucket, and that generates an event, and that event gets picked up by something called EventArc, which is an eventing system from Google Cloud, and it gets passed to the workflow, and the workflow will be kicked off, and then the workflow will run the whole chain, right? So I see this quite often. And actually, let's see if this works. And all of this, by the way, on GitHub, if you want to take a look. And I show you how to set it up with all the services and stuff like that. But the important part is basically once you deploy your services, the important part is to define the workflow. So the workflow is defined here. And again, it's same sort of thing. Like the main thing is that the workflow is getting an event. So it's event-driven. Then I have the steps that does the work. So the first step is to pick the file information from the event, so the bucket and the file information, then call the filter function, then check for the safety, and you can see that I'm doing a safety check right here, so I don't have to do this in the code. It's part of the orchestration. And if it's safe, then I go to the label step. But if it's not safe, then I end my orchestration, right? Then the label step does the labeling, the resize does the resizing, the watermark does the magic of combining the resized image with the labels. And you can see that the inputs are basically the inputs from the previous step. So it gets the resize response body for the bucket information and the file information, and it gets the label information from the labeling step as well. And then in the final step, I just return the HTTP code from each service. So that way I can make sure that my service, actually all of the services run, and it actually run successfully and save the image. So let's actually run this. I think I should have it in my workflow. So let's see, what was it called? Image processing. And if you look at the source, again, I really like the fact that I can see what's supposed to happen. And here we do the safety check. If it's not safe, we kind of end the orchestration. And we can see the executions, but to actually execute this, I need to upload an image. So let me go to the cloud storage. And then image. Yeah, there's an images input bucket where things will be saved. So let's upload picture. Let's say we're uploading this picture. Now this is uploaded, and if we go back to workflows, now this will generate an event, and if you look at image processing, you see that it's running, so that event went to workflows, and then all the chain is being run, and if we click on this, we can see the input. So the input was an event with this bucket information, and then image information as well, and you can see the logs that the image is safe, that's true, and then the output is done as well, so it's finished. The filter, label, resize, and watermark services, they all return 200, which means it ran correctly. And if we go back to our storage bucket, now we have the input, now we need to look at the output. We will see it was called river, so we can see that there's this river. So the river original one was in the input bucket. Now this 400 to 400 is the resize one, and this 400 to 400 with watermark is the one with labels that were extracted from this image using machine learning, and it was just put on top of the image as a watermark. So you can see how this kind of stuff works, and this pattern is something that I see quite often with orchestration. The next pattern is Saga pattern. So let's imagine that you have this, let's look at the GitHub again. Let's imagine you have these three services: order service, where you order something; the customer service, where you can reserve credit from the customer; and then again the order service to approve order. So the way it goes is that first you call the order service with create pending order, so that creates an order, but it's pending. Then you go to customer service and reserve a credit, make sure that the user has, the customer has credit. And then if that's successful, you go back to order service and say, okay, approve this order, right? Normally, if everything works, this is all you need. Just call these services in this order and everything just works. But what if your customer service actually is flaky? It doesn't actually run all the time. What can you do? Well, one easy thing that you can do is that you can, instead of making a single call from order service to the customer service, you can apply a retry policy. And you can just say, you know, let's call customer service one or more times, just in case it doesn't work. And that kind of gets rid of the transient issues, right? So if customer service is just down for a second or two, then this will work. And the way to do this in workflow is very easy. So now, in the version 1 of my workflow, I'm just doing the naive way. So I'm just calling create pending order, reserve credit, then approve pending order, right? So this is the naive way. But it's not going to work if things go wrong. Now, in the version 2, what we do is, again, we do the create pending order, but then in reserve credit, we do a try catch, well, try, retry, basically. But what this does is that this calls the customer service, and then if there is any problem, then it will retry, it will apply a retry policy. And that policy, you can define what you want, but there's also some default policies. And here I'm using an HTTP default retry policy. And this retry policy basically retries maximum 5 times on HTTP 503, which is service unavailable, and also with other HTTP status codes. I don't know all of these what they mean, but basically transit kind of failures. If that happens, then it will be retried 5 times. So this gets rid of the transient issues, and then once that's done, we can move on to the next step of approving the pending credit. But what if the issue is not transient, right? What if you come here and then you call the customer service, but you cannot actually reserve the credit, right? Because maybe the customer doesn't have credit, you know? What do? That's when Saga pattern comes into play. In Saga, you basically need to take a compensation step. So if something doesn't work, and if it failed in a permanent way, you need to define what should be unrolled, right? So what should you take a step back from? So what you can do in this case is that you say, okay, I call the reserve credit. If it's successful, I approve the order just like before. But if I cannot approve it, then I need to call my compensation step, and that step is called reject order. So we call the order service again, but with reject order. And the way you do this, again, in orchestration is if you look at ordering v3. Now here, we call our pending order just like before. Then we reserve our credit, again, with our default retry policy. So if there's something transient, we'll still apply that retry policy. But if something fails permanently, then we have this extra step that's called, well, we have this except branch where we define what happens if something failed permanently. And in here, you can define more steps. But what I'm doing is that basically I check if the error is not recoverable, like let's say it's like an internal server error or something else, then I call my reject pending order step. Otherwise, if it's something that I don't know about, then I just raise the error, right? And then if you look at the reject pending order, this is your compensation step. This is the Saga pattern. We'll just call the order service with rejecting the order with the ID that's been passed to us. So as you can see, like, things are not magical. You need to actually think about these failure conditions, and you need to apply steps or code or whatever to compensate for that failure. All right, another pattern is parallel steps. So as you saw so far in orchestration, things are like, one step after another step. Like it's always like sequential. But actually, it doesn't have to be. You can do parallel steps as well. I have this example. I won't run this, but I just want to show you quickly where I use a workflow to analyze the sentiment of Twitter using workflows. But I don't do it just for one Twitter handle. I do it for multiple Twitter handles. So as you can see, I have these arguments. And from the arguments, I picked some Twitter handles, so it's a list of Twitter handles. And then I have this step called process Twitter handles, but it's in a parallel keyword. What this means is that I'm running this in parallel branches, right? So here, this for loop, which loops over the Twitter handles, it will be run in parallel. So if you have 5, there will be 5 steps that are run in parallel. And then I go through, I won't bore you with the details, but basically I go through the tweets, I read the tweets, and then I analyze the tweets using the machine learning language API. And then I kind of look at the sentiment of the tweets, whether they're positive or negative. And then in the end, I have the result from each, and then I output like the Twitter handle and the sentiment. And I think I ran this before, so let's, just to show you the output of this. If you look at workflows, there's Twitter parallel. And then, yeah, if you look at the execution, but you can see, for example, I have these Twitter handles, like 5 of them. And then as an output, I get each Twitter handle with the sentiment score. Negative means it's negative, and CNN is more positive, Google is kind of positive, things like that. So doing stuff like this in parallel, it really speeds things up, but it's still very easy to see like how things should flow in your system. Okay, and another pattern I see is most of the stuff that I show you so far is serverless, right? It's serverless services, serverless orchestration. So there's no service to worry about, which is great. But sometimes you need service, right? Let's say you want to do a really long-running kind of calculation. Let's say you are calculating a prime number or something like that. You can't really run that on a serverless service. The reason for that being these serverless services, they usually have a timeout limit. They only run for 1 hour max. Let's say you want to run something for one week or 1 month or 1 year. In that case, you probably want to run on a VM, a virtual machine. But you don't need to worry about virtual machine so much if you use an orchestrator. So the idea here is that you will use workflows to kind of create the VM with the configuration that you want, deploy a container to that VM for your code, then run that VM for however long you want. And then once you have the result, get that result and just output that result in your workflow. So in this model, you're combining serverless orchestration with servers, But in the end, the server management is kind of abstracted away from you, so you don't have to actually worry about servers yourself. So I had this example that I won't show you because I'm running out of time, that you can take a look how to set that up as well. All right, and we have this case study that I won't have time for right now because I only have 5 minutes left, where we took an event-driven application. And this application was a picture-sharing application. There's actually a workshop around this if you want to look at it on your own. But in this application, we initially had this event-driven architecture, where, again, the user uploads a picture, then the picture goes to the storage bucket, then that generates a number of different event types. And these events, they go to different services, and each service do their own part. And in the end, we had these images analyzed and labeled and stuff like that. And we started having lots of issues with this architecture. Even though it's a simple kind of application, we started getting confused with different event formats because we had 3 different event formats. And depending on which service you're dealing with, you need to parse these different events. So we were getting confused in that. And the biggest problem that we had was that sometimes the user would upload a picture and something wouldn't work. We just didn't know where things didn't work. It wasn't obvious. So we had to always hunt through the logs and just to figure out like if something is not working. So what we did is that we took this and we rewrote it using workflows. And actually, when you look at this, it might look more complicated, but actually everything in these red boxes is just one service, Google Cloud Workflows. And in here, it became really obvious what should happen. So the user uploads the picture, then it goes to a function that triggers the workflow, and then the workflow does what it needs to do. It checks the event type, then it does the image analysis, then it calls the different services. So all of a sudden, we had structure into our flow, and we could see where things failed. So if something failed, for example, here or here in the steps, we could easily see it. So it really simplified our architecture. So the positives was that, we went from simple REST-based approach. We went from 3 different eventing formats to a simple REST-based approach, which was really refreshing. We got rid of a bunch of code because we don't have to worry about event parsing. We don't have to worry about some services. We could just do those in our orchestration. We did less setup because we don't have to deal with these different services, just one workflow service. And the error handling became really easy, as I mentioned already, because when something failed, we knew exactly where it failed, and that made things much easier for us. On the other hand, nothing is always good, so we had some negatives as well. First, the workflows service was a new service that we had to learn, so we had to learn how to write these YAML files in the right order and things like that. We always kind of went between like, should we do this in code in a separate function, or should we do this in YAML in workflows, right? And it wasn't always obvious which one is better or worse. Usually, if it's something simple, we would do it in YAML and let workflows do the work. But if it's something more complicated, we didn't want to do it in YAML because the YAML is not meant for writing code. In that case, we just wrote in code and just called the code from workflows. Debugging, testing, logging is not that great in workflows in the sense that you can't have a unit test for your orchestration, at least today. So that's why it was not easy for us to test it locally. Instead, we had to just deploy it and see if it worked or not. And we lost the eventing flexibility. So now if you need to introduce a new kind of service in your architecture, you can't just deploy it and hope that it works. You need to actually deploy the service and also change your orchestration and deploy your orchestration as well. So it's more involved in that sense. All right, I think I'm out of time. So if you want to learn more about workflows, this is the link. This workshop that I didn't really show you, but if you want to take a look, here's the link for that. And everything I showed today, it's in workflows-demos GitHub with more samples. Feel free to check it out. And the presentation is on speaker deck right here. So yeah, feel free to grab it. And I think there is a break right now. So if you have any questions, I'm happy to answer them right now. Thanks very much.